used as amplification, at which case it is used as a switching operation. So simply for this timing, just remember BJT is a three-terminal doped semiconductor device. Okay, be clear about each and every word. Three terminal because we are taking considering three terminals, and why it is doped because each region is doped. Okay, it is not the intrinsic semiconductor. Yeah, all regions are the extrinsic one. That means all are doped. Okay, that's why it is three-terminal doped semiconductor device, and its application is used as amplification of weak signal and also used as a switching operation. Is that clear?
Yes, sir.
Yes, sir.
Just give me a minute. Hello. No, no, okay, silent. Okay. So if you go for the physical structure, if you go for the physical structure of your transistor, so already I told this is a three terminal. Okay. So let us this is a their device and it has three terminal. Three terminal means three region. So one region is emitter, base, and collector. Okay. So these are the three region. So three region means that is nothing but two and all are doped. All are doped one. If all are doped one, so let's say it may be n type, it may be p type, or it may be n type, or in alternate case it may be p type, it may be n type, it may be p type. Okay, so by this we can call one as pnp transistor and other than npn transistor. Is that clear?
Yes, sir.
Yes, sir.
Okay, so remember BJT is a three-terminal doped semiconductor, and each terminal means each region. Each region it may be NPN or PNP, and remember in this case, in case of BJT, either P type is sandwiched between two N type or N type is sandwiched between two P type. Don't think that N and P, no. Okay, it is a three terminal doped semiconductor where one type of semiconductor will be sandwiched between two other two types of semiconductor. That means P type will be sandwiched between two N type like this case, or n type is sandwiched between two p type like this case. So based on that we have two types of structure like this, npn or pnp. Is that clear? Is that clear?
Yes, sir.
Yes.
Okay, and remember, so as it has three terminals, so each terminal we are giving some name. So first region is called as emitter, second one is the middle one is base, the another the remaining terminal is called the collector terminal. Okay, similarly you can say it is the emitter region, base region, collector region, and from each region we are considering one terminal. Okay, that's why three terminal. Okay, so in a BJT or in bipolar junction transistor we have uh, what we have one type of semiconductor region is sandwiched between two other type of semiconductor region, and from each region we are taking one terminals. Okay, so this is called emitter region, and the terminal taken out from that is called as emitter. This is called base region, and the terminal taken out from it is called the base terminal, and this is called the collector region, and the terminal taken out of that is known as collector terminal. Is that clear?
Yes, sir.
Okay.
Yes.
So as it is a N type semiconductor, P type semiconductor, again N type, or it may be P type, N type, P type. So here you can visualize a PN diode here and also a PN diode here. If I talk about this, if I talk about a PNP transistor, if I talk about a PNP transistor, I can think about a PN diode here and also a PN diode here. Yes or no? Like this. The structure will be like this. Yes or no?
Yes, sir.
That means I can consider my transistor as two diode back-to-back connection. Okay, two diode back-to-back connection. And remember one thing: if you understand the diode very well, then then only you can understand the transistor easily. If you have still doubt in the diode, then again you face difficulty in the transistor part, because transistor is nothing but simply a application of diode or a combination of diode. How the diode operate in the same manner here also operate. Okay, if you understand the characteristics, how the diode operates, what is forward bias, reverse bias, what happened, I mean all such conditions. Means so if you understand how completely how the diode operates, then only you can understand how the transistor will behave. Okay, because transistor is nothing but the two diode back-to-back connection. Okay, yes or no?
Yes, sir.
Okay. Again, one thing. Once you have a diode, you know this is P side, this is N side. Whenever P and N we are joining, then at the middle point or at the junction, you have some depletion region. Yes or no? So this is P
Yes,
type, this
sir.
is N type. At the junction, you have some depletion region. Yes or no?
Yes, sir.
Yes, sir.
In the same manner, tell me in PNP transistor, how many junction you will get?
Two.
Two,
Two
because
junction. Two junction.
two diode. In PN diode, you have one diode, so one junction. So here you have two diode. So you will get two junction over here. Okay, so that's why you have mentioned over here. So two junction one and junction two. Okay. So finally, what we came across? We came across that BJT is a three-terminal dope semiconductor device, and it has three regions and two junctions. So what are the two junctions? One junction between these two terminal and another junction between these two terminal. That means one junction will be between the emitter and base, another junction will be between the base and connector. Is that clear?
Yes, sir.
Okay. Remember the transistor. Okay. So first is known as emitter. First section is emitter. Then there is base. Then there is connector. Okay. The emitter may be N. This will be P. This will be N, or it might be P N P. Okay. And for this case, it will be called NPN transistor. For this case, it will be PNP transistor. Okay. And between emitter and base, there will be depletion. There will be a junction. There will be a junction. That is called junction 1, and between base and collector there will be a junction, because there is a wherever there is a diode there will be a junction, because you know in the diode whenever diode is formed at the joining of at the position when the P and N is joined, at that position you have at the junction you have some depletion region, that is called junction. Okay.
Yes, sir.
Okay.
Yes.
So sorry.
Yes, sir.
Okay. So next. So so come to the next one. So next so once we have the transistor, one is emitter, another is base, another is collector. Okay, we are not taking the dimension or doping, because already I told you, because all are three doped semiconductor. Doped semiconductor means मुझे इसको भी डोप करना होगा, इसको भी डोप करना होगा, इसको भी डोप करना होगा, लेकिन इसका डोपिंग कंसंट्रेशन सेम होगा या मतलब डिफरेंट होगा, that is also makes sense. Okay. So remember, while considering the emitter, base, collector, you have to follow some criteria. Follow criteria means related to width, related to doping. Okay, these are the information related to width and related to doping. I can say that the emitter is this much size, base is this much size, collector is this much size. So there is a strict rule we have to follow. So that is given. If you consider the width, so remember that the width of the collector is more than that of the emitter, than that of the base, and already it has some region. Okay, blindly we are not following these two rules. Okay, related to width and related to doping. Okay. Okay, there is also some reason. So first I will come to width. Okay. So remember, the width of the collector is largest, then width of the emitter, then width of the base. Okay. Okay, this trend we are following in case of the transistor. Then there is also a reason why you are thinking about this, why the collector region is more, because as the name suggests, if you go to the previous slide, here, so this part is called emitter, this part is called collector. So what is the meaning of emitter? Emitter means it will generate the carrier, and collector means it will collect the carrier. Base means it just transfer from input to output, as the name suggests. Yes or no?
Yes, sir.
Okay. That means emitter will generate the carrier and collector will collect the carrier. And the middle one, base, will just pass the thing input to output. Okay. Is that clear? For example, suppose you are the customer, vendor is someone, and the middleman is just transfer the material from company or from organization to you. In the same manner, emitter will generate the carrier. Generate the carrier means that electron, whatever electron or hole, whatever you tell here. Okay, that will generate the carrier, and that carrier will pass through the base, and then it will be collected over the collector. That's why the name is called collector. Is that clear?
Yes, sir.
Yeah. So that's the reason. That's the reason. That's the reason you can say what is the basic nature. Suppose you want amplification, leave about that amplification. What is the basic nature? Suppose you are transferring something at the output side. What you want? You want that more number of collector, more number of carriers should be collected. Yes or no?
Yes,
Yes,
sir.
sir.
Suppose someone sending you 1,000 rupees. Suppose someone sending. Suppose your parents send you 1,000 rupees through bank. What you want? You want that all 1,000 rupees should come to your account without any bank charge. Yes or no? Without any bank charge, all thousand will come to your account. Yes or no?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
And here your father money will behave as a emitter, your bank will behave as your base, and you behave as a collector. You want more number of more you want more rupees will come, whatever the father will send, exactly maximum of that money will credited to your account. You want that. Okay. And bank, what is the use of bank? It will take some charge. It will 100% will take some charge, but you want the bank charge to be very very small. Yes or no?
Yes.
Yes, sir.
So as you want that whatever your parent has provided or sent to you, the maximum of that amount will be credited your account. That means in the same manner here also, collector also want more number of carrier. As collector wants more number of carrier, for that purpose the width of the collector will be more. Now you are clear why the collector width is more, because to what collect more, because we have to collect the more carrier. Okay, because of that reason the collector area will be more. Okay, then emitter area, then why base area is less? Okay, the base area is less because of the reason that in the base what will happen, there will be recombination. जिसको बोल रहे होते हैं ना, if bank charges will be more, then there will be more deduction in the money, and less amount of money will be credited in your account. In the same manner you can think that if your base area will be more, then there will be a recombination. So what do you mean by recombination? The electron hole pair get recombined. As electron hole pair get recombined, the number of free electron will reduce. Is that clear? If the number of free electron will be reduced, then less number of carrier will move to the collector. Because of that reason, what should be the intention? There should be less recombination. 100% will be there. No doubt, bank charge will be there, but you want a bank where bank charge will be less. यस और नो? तुमको ऐसा बैंक सोचना पड़ेगा जिस बैंक में क्या होगा, चार्जेस कम होगा। इसी तरह तुम ऐसे सोचोगे जैसे तुम्हारा रिकम्बिनेशन कम होगा, सो योर रिकम्बिनेशन विल बी लेस ओनली व्हेन द विड्थ इज लेस। जितना विड्थ ज्यादा होगा उतना टाइम मिलेगा कैरियर को रिकम्बाइन होने के लिए। So indirectly what you should do, you have to decrease the length of the base. Once you decrease the length of the base, okay, it is very difficult for the carrier which is coming from the emitter side to recombine. Is that clear?
Yes, sir.
अभी समझ में आ रहा है? What is the reason we are taking the base width is less? Remember, each can be a one question. Why the width area? Why the collector has largest width? Base has least width. The reason is the collector width is more because you have to collect more output, because this is your output terminal and you want more output. And why the base width is very less? Because to decrease the recombination rate. So because if you decrease the recombination, then then the more number of carrier will move from the emitter side to the collector side, क्योंकि बीच में तुम्हारा रिकम्बिनेशन हो जाता है। रिकम्बिनेशन मतलब न्यूट्रलाइजेशन ऑफ द कैरियर, यू कैन थिंक अबाउट। ओके, होल इलेक्ट्रॉन्स मर्ज हो जाते हैं, सो thereby they decrease the number of carrier. Okay, is that clear?
Yes, sir.
Okay.
Yes, sir.
Then coming to the next, coming to the doping test. So why doping? So if you talk about the doping, doping of emitter is high. So you can say emitter is heavily doped, collector is moderately doped, and base is least doped. Okay. Again, there is also reason why the emitter is heavily doped, because emitter will generate emitter. What is the function of emitter? It will generate the carrier. हमने पढ़ा है ना, BJT is a three terminal doped semiconductor device. One terminal is called emitter, another terminal is called base, another terminal is collector. तो emitter का काम क्या होता है? The emitter will emits, it will generates, it will क्या generate करेगा? It will generate the carrier. Okay, अगर वो carrier generate करेगा तो तुम्हारा पहला intention क्या क्या होगा? It should generate more number of carriers. तुम तो अभी तुम्हारे पास पॉकेट मनी नहीं है, तुम अपने पापा को बोलोगे सेंड द मनी, तो तुम क्या सोचोगे? 100 रुपया, 10 रुपया? You think about that more number of rupees will be credited in your account. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. In the same manner, here you can just think about emitter should generate more number of carrier. So how the emitter should generate more number of carrier? Emitter is a what? That emitter, the base collector, all are doped variety. But how the doping is related to your generation of the carrier, because what is the definition of the doping? What is the definition of doping? Adding impurity to the semiconductor to increase its conductivity. तो डोपिंग का मतलब क्या होता है? To increasing its current carrying capability, or to increase the carrier, free carrier. We are going for the doping. Yes or no? हम डोपिंग
Yes,
क्यों
sir.
कर रहे हैं?
To increase the conductivity.
Conductivity is to increase its conductivity means to generate more number of carrier. तो हमें अभी पता चल गया कि इमिटर से हमको ज्यादा कैरियर लेना चाहिए इमिटर से. Okay, that means emitter should provide more number of carrier. तो undoubtedly out of this three terminal, तो emitter को हमको ज्यादा डोप करना पड़ेगा. Uh, if you dope more that emitter section, then emitter will generate more number of carrier. Now you are clear why that emitter is heavily doped. This is the only reason that emitter is heavily doped. Clear?
Yes, sir.
Okay, so as the emitter is heavily doped, similarly the collector is moderately and the base is least dope. Okay, because जितना तुम उसको least dope करोगे उतना recombination कम होगा, उसके पास कैरियर कम होगा, उसके पास कैरियर कम होगा तो वो रिकम्बाइन नहीं कर पाएगा. ठीक है. Okay, so simply remember the width trend or width order and the doping order of three region: emitter, base, and collector. So remember regarding to width, so the collector has highest width, emitter moderate, and the least width is base. So remember, whenever you will draw any figure of your transistor, any figure of the transistor, just like this, so always give a largest section or the largest area to what? Collector section. So if this is my emitter, I will say this is my base, this is my collector. Okay, comparison to all regions, so your collector should have more thickness, or you can say more area. Okay, and if you talk about the doping, so emitter is heavily doped, this is moderately doped, and this is least doped. You have to remember the trend regarding its width and doping. Is that clear?
Yes, sir.
Okay, so this is just a cross-sectional view. As I told, if you go for a means its construction, it means how it is constructed. Okay, if you go to depth study of this, so you will understand this is nothing a sandwich. Already I told you, the semiconductor is a three-terminal device, and here your P-type is sandwich between 2n type, or n-type is sandwich between 2 P-type. If you go for the cross-sectional view of this transistor, you can see you have one region here, another sandwiched semiconductor, again another material. So if I consider NPN, so first one is N, this is P, this is N. If I will consider PNP, so this will be P, this will be N, and this will be P. And from each of the section, I am taking one and ohmic content. Ohmic content means terminal. Okay, one will be emitter, base, collector. Is that clear?
Yes, sir.
Okay. So now come to symbol. Okay, if you talk about the symbol, so as it is three-terminal device, so the symbol will be like this. I'll let them mention over here. So this is the three-terminal. Okay, but regarding, okay, so these are the three terminals. So this is the symbol of the transistor. But already remember, this is the symbol of your what? Tell me, this is the symbol of your
Transistor.
transistor. So how many terminals are there? I told you there are three terminals.
3.
Three
And
term.
what are the emitter, base, and
Base
collector?
collector.
And the middle one is always
Base.
base. So
Base.
no,
Base.
no doubt this will be my base. No doubt. Yes or no?
Yes, sir.
Then
Yes,
out,
sir.
then out of these two, one will be emitter, another will be collector. But now my next target is which one is my emitter, which one is my collector. Okay, I have to, because one will be emitter, another will be collector. Again, this is one confusion. This is one confusion how to select emitter and collector. Second confusion is there is two type of transistor. One is NPN and another is PNP. Again, how to identify this? Okay. So remember, that's why there is a aroma. There is a aroma. So if you go to the structure of your PNP, emitter, base, collector, emitter, base, collector. Okay. So this is the structure. Okay. Already I told you that the carrier will be generated over which section? Tell me, carrier किस section में generate होगा?
Emitter.
emitter. तो इधर से इधर तुम्हारा क्या फ्लो करेगा? कैरियर. अगर इधर से इधर कैरियर फ्लो करेगा, करंट इधर से किधर फ्लो करेगा? इधर से फ्लो करेगा. Yes. That means always remember the equation I E is equal to IB plus IC. बिकॉज इधर भी एक सेक्शन होगा ना, तीन टर्मिनल में तीन सेक्शन, अगर तुम उसको कुछ वोल्टेज दोगे तो फाइनली आई ई इज इक्वल टू आई बी प्लस आई सी. ओके, ठीक है. एंड रिमेंबर दिस आई मीन्स करंट थ्रू द इमीटर. ओके, उसको हम क्या करेंगे, एक आरो मार्क में शो करेंगे. ओके, एंड दैट आरो मार्क इंडिकेट दैट टर्मिनल इज कॉल्ड इमीटर. ओके, so let's say I put your arrow mark over here. That means this is my emitter, 100%. This is my emitter, and the remaining one is collector. So my first confusion is over. And
Yes.
then come to second confusion, whether it is NPN or PNP, because that is also one type of transistor, NPN transistor and PNP transistor, because both the transistor can be symbolized as one symbol. एक ही symbol में दोनों transistor को मैं express कर सकता हूँ क्या? नहीं. That's why how to declare that it is NPN or PNP. If the arrow mark is outward, if the arrow mark is away from the base, so that is called what? NPN. If this is
NPN.
towards the base, if this is towards the base like this, that agar arrow mark ऐसा होगा, okay, like this, okay, then it will be called as PNP. Okay, means the shape will be like this for PNP. If 100% is base, so if this will be arrow mark will be here, so that will be collector, that will be emitter, this will be collector, and this is called PNP. Okay, and if there will be transistor arrow mark like here, that will be NPN. Is that clear?
Yes, sir.
Okay.
Yes, sir.
So that's why we have given the symbol, that is NPN. Look, this is the middle one is base. Arrow mark is here, so arrow mark is here, so 100% is emitter. This is emitter. And how to check whether it is NPN and PNP? If the arrow mark is away from the base, NPN, towards the base, PNP. Clear? Okay. Next. Okay. So simply BJT. So whatever we just now discussed, the same means a brief summary of that fact. So simply BJT is defined as a two junction or two PN junction connected back to back. That's why knowledge of diode is very much important in understanding of the transistor. Whatever I told you just before 10 to 15 minutes, because the understanding of diode is too much required. Okay, it is essential. It is essential to understand the transistor. अगर ट्रांजिस्टर को समझना है तो डायोड को समझना है. Yes or no? Because transistor is nothing but two PN junction diode connected back to back. Okay. Is that clear?
Yes, sir.
Yes, sir.
Okay. General second. Now BJT is okay. We got what is the BJT. Again, we have two types of BJT. I told you that is NPN and PNP transistor. But most of the time we'll talk about NPN transistor instead of the PNP, because in most of the discussion or most of the derivation, okay, we'll go for the NPN transistor. Why NPN transistor? Just look about the structure. If it will be emitter, this will be base, this will be collector, and if this is my emitter, so either it will be PNP or it will be NPN. Okay. Okay, if I consider my PNP, then what is my majority here? Majority will be whole. Majority will be whole. And if I consider my N means NPN transistor, so my emitter is N type, and here the majority will be, tell me,
Electrode.
electron.
Electron.
That means in case of your PNP transistor, your hole will be moved from this section to this section, and if it will be NPN type, your electron will move from this to this side. And if you talk about the speed or mobility, the mobility of electron is too much greater than the mobility of hole. Okay, mobility of electron is too much greater than the mobility of hole. That's why most of the time we consider the NPN. Is that clear?
Yes, sir.
Okay.
Yes, sir.
So this is all about your BJT. This is all about your BJT. So again, come to the name of this BJT. So bipolar junction transistor. So why it is called bipolar? The name bipolar is because of two poles. If two poles means two polarity things, means one is electron, another is hole. Both take part in conduction. Both take part in conduction. That's why the name is called bipolar. Okay. Why junction? Why junction? Because in this transistor we have creating two junction between emitter and base, junction between base and collector. Because
Yes,
of
sir.
that two junction, we have a keyword junction over here. The last one is transistor. Okay, already we defined what is the transistor, because transfer of resistor, that means we are changing the resistance level one to another. Because if you go in details of this in this BJT, you will understand that in case of a BJT, your junction one means the first junction between the base and emitter is forward bias, and in forward bias resistance is low or high. In forward bias resistance is low or high. फॉरवर्ड बायस में डायोड का
Low.
रेजिस्टेंस लो होता है. Okay, and in reverse bias it is high. Okay, that means in the junction 1 will be forward bias having low resistance, junction 2 is reverse bias having high resistance. That means you are changing the resistance from low to high. That's why it's called transfer of resistance. So that's what that is. Means the main intention is you have to give your input signal in the input side, in emitter side, where you have low resistance, and you will consider your output across your collector. Okay, that means at high level side. That is output. That means you have to feed your weak signal at low resistive part, and you will collect your output from the high resistance. That's why BJT transfer the signal from high level to from low resistance level to high resistance level. So that is the basic meaning of this bipolar junction transistor term by term. Okay, समझ में आएगा each term का definition. Bipolar क्या है, junction क्या है, transistor क्या है.
Yes, sir.
So the bipolar means two poles you are considering, junction means you are considering the two junctions, and transistor इसलिए बताया जाता है कि because at the input side you are giving the weak signal, and the output you are collecting the at the input side you are giving weak signal having low resistance level, and the output side you are taking the output and that part having high resistance. That's why the bipolar junction transistor. Is that clear?
Yes, sir.
ओके, नेक्स्ट कम टू रीजन ऑफ ऑपरेशन. मतलब उसको कैसे तरह ऑपरेट कर सकते हैं. ठीक है, ये सब सपोज तुम्हारे पास दो रूम है, तुमको बोला जाएगा एक को बेडरूम करोगे, एक को स्टडी रूम करोगे. तो तुम बोलोगे सर इधर ये बेडरूम होगा, ये स्टडी रूम होगा, अदरवाइज ये स्टडी रूम होगा, ये बेडरूम होगा. ये सब
Yes, sir.
in the similar manner here in case of transistor, already I told you there are three regions. So first region is emitter, so this is the base, and this one is collector. Okay, and each have सब टर्मिनल. तो इमीटर से टर्मिनल है, बेस से टर्मिनल है, कलेक्टर से भी टर्मिनल होता है. सबका एक टर्मिनल होता है. ठीक है, तो नाउ व्हाट यू शुड बी, यू हैव टू, बिकॉज दिस इज जंक्शन 1, दिस इज जंक्शन 2, दो ही जंक्शन होता है. ठीक है, डायोड की जैसा. ये सब नो, ये सब नो.
Yes, sir.
Yes, sir.
अगर तुम डायोड को ऑपरेट करना चाहते हो तो डायोड को भी वोल्टेज दोगे ना. यस सर. अगर तुमको पीएन डायोड को बायस करना है तो क्या होगा, पीएन डायोड के अक्रॉस में तुमको वोल्टेज देना पड़ेगा, इधर पॉजिटिव और नेगेटिव व्हाटएवर. तुम केस पढ़े हो ना, केस 1 that is VD is positive, VD is negative, VD is 0. Yes or no? In the similar manner you have to provide the voltage over here. Yes or no? Okay. Yes or no? तो मतलब क्या होता है, अगर तुम वोल्टेज दोगे तो आइदर द डायोड विल बी फॉरवर्ड बायस और डायोड विल बी रिवर्स बायस. यस और नो?
Yes, sir.
तो सिचुएशन
Yes, sir.
ऐसा हो सकता है बिकॉज ऑफ दैट पोटेंशियल ये दोनों फॉरवर्ड फॉरवर्ड भी हो सकता है, और ये फॉरवर्ड होते हुए ये रिवर्स भी हो सकता है, और ये रिवर्स होते हुए ये फॉरवर्ड भी हो सकता है, और दोनों रिवर्स भी हो सकते हैं। यस सर नो?
Yes, sir.
Yes, sir.
और कुछ पॉसिबल केसेस हो सकता है क्या?
No, sir.
Okay. So remember, out of all such cases, this case when the input junction is forward bias, output junction is reverse. This is called amplification case. Okay. इधर तुम्हारा सिग्नल का एम्पलीफाई होता है, and here in this situation, this is gives like an amplifier. Okay, is that clear? And another section is whenever whenever both will be reverse. मतलब ये वाला रिवर्स होगा, ये वाला रिवर्स होगा, बिकॉज इफ इट विल बी एनपीएन, तो उसी हिसाब से उसको मतलब उसको पॉजिटिव या नेगेटिव सप्लाई दोगे। यस और नो? रिमेंबर द बायसिंग नेचर में, बिकॉज इफ इट विल बी एनपीएन, तो इसको रिवर्स करोगे मतलब इधर एक पॉजिटिव पोटेंशियल, इधर एक नेगेटिव पोटेंशियल, और इसको रिवर्स करोगे तो इस साइड एक पॉजिटिव, इस साइड एक नेगेटिव। यस और नो?
Yes, sir.
Yes, sir.
So you just remember the biasing nature only. Okay, if both the junction are reverse bias, so in this case it will be like a cut-off. So we'll discuss why it is called cut-off, why it is called amplifier. Okay, listen this case. Okay, if this will be forward bias, this will be reverse. If this will be forward bias, we'll talk about NPN transistor. Okay, because most of the time we talk about NPN transistor. So emitter, base, collector. So let's say this is N, this is P, this is N. So three terminal 1, terminal 2, terminal 3. Okay, so what we will do here, this is forward bias, so इसको forward bias करने के लिए नेगेटिव को N साइड कनेक्ट करना है, पॉजिटिव को P साइड कनेक्ट करना है। ये सर नो?
Yes, sir.
No, sir.
Yes, sir.
नो
What?
नो सर, नो सर। हेलो, who told that no? What do you mean by forward bias? P साइड के प्लस P साइड को पॉजिटिव टर्मिनल में कनेक्ट करना है, N साइड को नेगेटिव, दिस इज कॉल्ड फॉरवर्ड बायस।
Yes, sir. Yes.
यस, ओके। सो लुक, इसलिए तो मैंने इधर लिख लिया, दिस इज एन, तो एन को नेगेटिव में कनेक्ट करना है, पी को पॉजिटिव में करना है। तो अभी ये तुम्हारा अभी ये जंक्शन फॉरवर्ड बायस हो गया, तो ये जंक्शन को लिए इसको उल्टा करेंगे, नेगेटिव इधर रखेंगे, पॉजिटिव इधर रखेंगे। तो ये अभी इसको सॉरी इसको भी मुझे रिवर्स करना है ना जंक्शन टू को, तो ऐसे होगा। यस और नो?
Yes, sir.
ओके, तो नाउ दिस इज रिवर्स बायस। तो ऐसे करने से कैसे तुम्हारा एम्पलीफाई होता है, जस्ट लुक। ओके, तो ये फॉरवर्ड बायस हो गया। अगर ये फॉरवर्ड बायस हो गया तो अभी डिप्लीशन विड्थ क्या हो जाएगा, बहुत कम हो जाएगा।
Yes, sir.
ओके, अगर ये तुम्हारा डिप्लीशन विड्थ बहुत कम हो जाएगा तो इजीली कैरियर इधर से इधर मूव कर जाएगा। ठीक है,
Yes, sir.
ओके। एंड यस और नो? ये and जो भी तुमको इधर ट्रांसफर तुम किए, whatever thing you have just transfer or the carrier just moved over here, then क्या होगा, and that part you want over here because you want output across your collector के across में तुम output निकालना चाहते हो। अगर तुम collector के across में output निकालना चाहते हो तो क्या then क्या होना चाहिए, that part should be open because for example look about a simple circuit. Suppose you have a voltage source, okay, you have a resistor over here, okay, then what will happen, if a circuit will be closed then there will be voltage drop। yes or no?
Yes, sir.
अगर इधर कुछ और एक
Yes.
डिवाइस वगैरह कुछ होगा तो इधर कुछ ड्रॉप मिलेगा। ओके, बट इफ द सर्किट विल बी ओपन, अगर सर्किट तुम्हारा ओपन हो जाएगा देन क्या होगा, यू विल गेट ओपन सर्किट वोल्टेज। ओपन सर्किट वोल्टेज मतलब इधर जितना भी वोल्टेज मतलब होगा सोर्स के अक्रॉस, इफ यू मेजर द वोल्टेज अक्रॉस दिस एग्जैक्टली सेम वोल्टेज यू विल गेट। दैट्स व्हाई यू वांट द सेक्शन टू बी ओपन। ओके, and in case of your diode, your opening situation will achieve when the diode will be reverse bias. So that's why this part will be reverse bias. You have to maintain, and under that case, whatever the carrier you are transferring from this to this, okay, corresponding large output will be collected across the terminal, which is nothing but your objective of the amplifier। Also amplifier का objective क्या होता है, तुम जितना भी दे रहे हो मैक्सिमम टू मैक्सिमम वो मिलना चाहिए। तो उसके लिए तुमको क्या करना पड़ेगा, सेकंड जंक्शन को रिवर्स करना पड़ेगा, कट अप करना पड़ेगा। तो कट अप मतलब रिवर्स बायस में रखना पड़ेगा। ठीक है,
Yes, sir.
Okay, so this is the region you have to remember. Whenever input junction is forward bias, output junction is reverse bias. At that time, both the transistor is used as an amplifier. The second case is when both will be reverse bias. अभी सोचो, अभी मैं इसको भी रिवर्स बना दूंगा, इसको भी रिवर्स बना दूंगा, तो मतलब क्या क्या होगा, ये वाला ट्रांसफॉर्म हो सकता है क्या, ये वाला ट्रांसफॉर्म होगा क्या?
क्या पहला वाला भी नहीं होगा?
नहीं होगा. अगर पहला वाला नहीं होगा तो मतलब क्या, डिवाइस एंटायरली कट ऑफ हो गया, कुछ सप्लाई भी नहीं हुआ, कुछ मिलेगा भी नहीं. सो दैट मीन्स दैट इज कट ऑफ. जनरेट भी नहीं होगा, ट्रांसफर भी नहीं होगा, दैट्स कॉल्ड कट ऑफ. ओके,
Yes, sir.
Yes, sir.
इज दैट क्लियर?
Yes, sir.
So in this manner, the other two sections means one will be behaved as a switch, on switch, another will be behaved as a off switch. Okay. So basically you have to remember this amplifier. Whenever the input junction means J1 is forward bias, junction 2 is reverse bias. At that time your diode will be behaved as an amplifier. Okay, amplifier. Similarly, when junction 1 is forward bias, junction 2 will be reverse bias. Forward bias, and both will be forward bias. At that time, this will be actually like an on switch. Okay, we'll discuss about what is mean the on switch and what is mean off switch. At that time, what will happen? Maximum current will be there, so there will be no look. If you, I think you might have gone through the VI characteristic. Sorry, not transistor. Okay. अगर तुम इसका ट्रांजिस्टर अभी पढ़ोगे, अभी ट्रांजिस्टर का अगर तुम आउटपुट कैरेक्टरिस्टिक लोगे तो ऐसा ही शेप आएगा. ठीक है, यस और नो?
Yes, sir.
Yes,
Yes, sir.
In this shape, remember this part is called at saturation level. Saturation level means constant. Okay, at this constant, that is called on state. But here only look, जब ऐसा ही slope आता है ना, whenever you are getting a slope like this, okay, and this is linearly in this type of slope, at that time change in input and change in output, उसमें थोड़ा variation होता है. Yes or no? And because of that case, we are considering this part as a means amplifying region. लेकिन ये पार्ट तुम्हारा एम्पलीफाइंग नहीं होता है, because this will give constant output. Yes or no?
yes, sir.
Okay, because this is constant output, this section is known as on section. Okay, so that's why we just discussed that whenever the input junction is forward bias, junction 2 is reverse bias, that's called amplifier section, and if both will be forward bias, this will be on, and if both will be reverse, that will be off, and the first one will be reverse, second one will be forward, that will be cut off. बिकॉज अगर तुम्हारा पहला सेक्शन रिवर्स हो जाएगा तो कभी जनरेट भी नहीं हो पाएगा. अगर जनरेट नहीं हो पाया, देन इफ दिस विल बी फॉरवर्ड, देन देयर विल बी नो इशू, बिकॉज स्टार्टिंग इट विल बी कट ऑफ. यस और नो?
Yes, sir.
Yes, sir.
So just remember the region of operation. Sorry. Just remember the region of operation. That means when first two junctions are one is forward bias, another is reverse bias. So that is called active region of operation. Remember that is called active region of operation. And in active region of operation, your diode will be as a amplifier. Okay, and in caught up region, it will be as an off switch. And if both will be forward bias, that is called saturation region, that is behaves like on switch. Okay, and if the first junction is reverse bias, second one is forward bias, so inward, that is more rarely used. For mostly you will use the transistor, as already some of you just told, it behaves like amplifier and a switch. Already in the application part we just discussed why the transistor is used. So transistor is used for the amplification purpose. Also control means on off. Okay, so that means mostly we will discuss about this amplifying action and this on off. Okay,
Yes, sir.
so you have to just stick with this operation in this table because it's too much important regarding the region of operation. Next. Okay. Now how the amplification is done, let us discuss. So already I told you amplification will take place in which case when the junction 1 will be forward bias and junction 2 will be
Reverse biased.
reverse bias. अगर ये ऐसा situation होगा then at that time there will be amplification, and tell me if junction 1 will be forward bias the resistance will be low, and when it will be reverse bias the resistance will be high. Yes or no?
Yes, sir.
तो let us come to इस इक्विवेलेंट सर्किट. तो अगर मुझे पता चलता है कि इनपुट साइड में मेरा लो रेजिस्टेंस होगा तो मैंने क्या किया, इनपुट साइड में एक सर्किट बनाया, इक्विवेलेंट सर्किट बनाया जिसका रेजिस्टेंस कम होता है, एंड आउटपुट साइड में एक सेक्शन आउटपुट, बिकॉज आउटपुट साइड भी एक सर्किट बनेगा, बिकॉज इनपुट आउटपुट दोनों अलग अलग है, बिकॉज इनपुट में एक डायोड होता है, बिकॉज इनपुट ऐसा होता है आउटपुट में ऐसा होता है. सो इसका एक इक्विवेलेंट बना होगा, इसका भी एक इक्विवेलेंट बना होगा. तो इसका इक्विवेलेंट ऐसा होता है जिसका लो रेजिस्टिव होता है. तो आउटपुट में क्या होता है, ऑलरेडी आई टोल्ड यू आउटपुट इज रिवर्स बायस, मतलब उसका रेजिस्टेंस हाई होगा तो उसको मैं कैपिटल आर में मींस को सिंबलाइज कर लिया. तो अभी क्या होगा, सो लेट अस आई गिव माय इनपुट वोल्टेज वी आई. ओके, so I know that input, that weak voltage Vi is nothing but I into small r, and V naught output is nothing but I into capital R. Okay, so and as here the resistance value is more, I can say this V naught will be more than Vi. So V naught is more than Vi. So as V naught is more than Vi, so I can say that my output voltage is increasing. So that is called voltage amplification. It is called. Tell me.
Yeah, please.
Voltage amplification.
Okay, that's called voltage amplification. Okay, so now just go to the working. Now just go for the working. तो कैसा है काम कर रहे हैं. Okay, and we'll just discuss about the NPN variety. Already told you what is the reason for behind considering the NPN type, because mobility of the electron will be too much better than mobility of hole. That's why we are talking about your NPN. Okay, and again why we are considering only about the active mode, because we are interested for the amplification. So that's why most of the time we'll discuss about NPN transistor in active mode. Okay, remember NPN transistor in.
Active mode.
Okay, so this is this is structure. This is structure, or you can say the circuit of that NPN and active mode. So your input junction NPN, so N is connected to negative side, P is connected to positive side. So now this diode is the first section is forward bias, and the second one N is connected to positive, P is connected to negative. So second junction is reverse bias. So 100% sure it is active one. Yes or no?
Yes, sir.
Okay. So what then look at this expression. What you want over here? इसमें तुमको क्या चाहिए? तुमको इधर चाहिए कि इधर जितना भी इलेक्ट्रॉन रहेगा मैक्सिमम टू मैक्सिमम इलेक्ट्रॉन विल रीच ओवर हियर, इधर मिलना चाहिए. यस और नो? ऑलरेडी तुमको
Yes,
पता है. And very less amount of electron will be or carrier will be recombined over here. Yes or no?
Yes, sir.
तो मतलब बहुत लेस परसेंटेज ऑफ दिस वन, मतलब तुम्हारे पेरेंट्स तुमको जितना भी भेजे होंगे, जितना भी 1000 हो 1 लाख हो, जितना भी, उसका वेरी स्मॉल अमाउंट should should deduct as a bank charge. You want that? Yes or no? That is a basic thinking. Yes or no?
Yes, sir.
Okay, so and maximum will reach to you. Yes or no?
Yes, sir.
So maximum I can treat as 1, and minimum is 0. So maximum is 1. In terms of percentage it will be 100%, it will be 0%. So in terms of if you talk about the fraction, this will be 1. Okay,
okay.
Yes, sir.
and ideally it will be 1, but never it will be 1. That will be less than 1, means more towards 1. Yes or no?
Yes, sir.
Okay,
Yes, sir.
let that factorial be alpha. मैं उसको alpha symbolize कर लेता हूँ. Let's say this alpha will be more towards 1. Okay, that means तुम्हारा पापा तुमको जितना मनी भेजेंगे, let that money will be n, उसका alpha times of n तुम्हारे पास पहुंचना चाहिए, और very less amount. तो alpha अगर चला गया और कितना बच जाएगा, 1 minus alpha, and 1 minus alpha times of that n will be deducted as your bank charge. In the similar manner, just think if emitter has n number of carrier, so at the collector you need most of the carrier. Most of the carrier should be collected over this collector terminal. So that's why alpha, because alpha is towards 1. Okay, and very less means if alpha is coming over here, then 1 minus alpha will be recombined, and this alpha, if alpha will be more, so 1 minus alpha will be very less. For example, if I say if this will be 100, and alpha will be, I can say 0.95, that means 0.95 times of n means most of the electron, means most, that means 100, that will be 95 electron or carrier will come across here, and here 1 minus 0.95 is nothing but 0.05 times of 100, that means only 5 will be here, very less. Yes or no?
Yes, sir.
Okay. So that is the description I have made over here. That means you want most of the carrier which is at the emitter side will reach over here. Okay, and mathematically I give just like a symbol. If there will be n number of carrier and you want most of the carrier means that means I can say alpha n. Okay, where alpha is a fraction that is towards to 1, that is most of the carrier you are getting at the collector, and very less amount, that means 1 minus alpha times of your majority will be recombined as a loss. Okay, is that clear?
Yes, sir.
Yes, sir.
तो उसको इधर वही लिखा है, because of this reduce barrier potential across junction 1, so electron from inside cross the junction and move to the, देखो इधर तुम्हारा क्या हो गया, तुम्हारा आज यू हैव फॉरवर्ड बायस जंक्शन 1 को तुमने फॉरवर्ड बायस किया है, तो इसीलिए क्या होगा, इजीली तुम्हारा क्या होगा, इलेक्ट्रॉन फ्रॉम द इनसाइड में जो भी मेजोरिटी हो पी साइड में इजीली चला आ जाएगा एंड मूव टू द बेस, तो बेस के अंदर जाएगा, तो बेस में क्या होगा, रिकम्बाइन होगा. ओके, एंड अगर recombine होगा, then there will be reduction in the carrier. That's why we are making the depletion region, that width of the base will be less, इसलिए हम उसको कंसीडर करते हैं, width को लेस कंसीडर करते हैं, एंड लीस्ट डोप करते हैं उसी रीजन से, उसको रिकम्बिनेशन हमको क्या करना है, डिक्रीज करना है. दैट इज द रीजन. रिमेंबर अनदर पॉइंट. ओके, टू डिक्रीज दिस रिकम्बिनेशन, ओके, वी आर मेकिंग लीस्ट विड्थ, जो भी हमने मतलब स्टार्टिंग 5 मिनट्स में कवर कर चुके हैं. वी आर डूइंग फॉर द लीस्ट विड्थ फॉर द बेस, एंड आल्सो वी आर डूइंग फॉर द लीस्ट डोपिंग. ओके, तो बेस के लिए क्या होता है, लीस्ट विड्थ होता है, लीस्ट डोपिंग होता है, because to decrease the recombination rate. Okay,
Yes, sir.
and you want maximum of your carrier will move to the collector side. Okay, so that's why again I mentioned over here, that's why हमने बेस के लिए ये वाला चीज अडॉप्ट किए हैं, small width, lightly doped. Okay, because this combination gives you low recombination. Okay, is that clear?
Yes, sir.
और इसका एडवांटेज क्या है,
Yes,
जो भी मैंने बताया इसको इधर मैंने नोट डाउन किया है. इसका एडवांटेज क्या है, बिकॉज if you do this type of configuration for this base, okay, very small recombination of electron will from emitter and most of the electron pass to collector. तो बहुत कम recombine कर जाएगा, बीच में लॉस हो जाएगा और मैक्सिमम इलेक्ट्रॉन पास करेगा. ओके, दैट इज द मेन रीजन. ओके, तो अभी समझ में आ रहा है ना कितना तक?
Yes, sir.
Okay, so next होता है junction to is reverse bias. As the junction to, so look, so there is a junction 1, there is a junction 2. अभी junction 1 फॉरवर्ड बायस हो गया, junction 2 रिवर्स बायस हो गया. तो अभी क्या करेगा, कैरियर इधर से इधर फ्लो करेगा. यस और नो? Yes or no?
Yes, sir.
Okay.
Yes,
As the junction 1 is forward bias, so इधर क्या फ्लो करेगा, मेजॉरिटी विल फ्लो. यस और नो?
Yes, sir.
लेकिन इधर से मेजॉरिटी फ्लो कर सकता है क्या, क्योंकि रिवर्स बायस से मेजॉरिटी फ्लो नहीं करता, हमको पता है, because very less amount of current you will get, that in terms of micro, that means minority will flow. Yes or no?
Yes, sir.
Yes.
That means in active operation mode, in active mode of operation, the junction 1 is forward bias, junction 2 is reverse bias, which indirectly means that, okay, I have majority plus minority carrier moving. यस सर नो, मेजॉरिटी भी मूव कर रहा है उसके साथ माइनॉरिटी भी, माइनॉरिटी बट दैट इज वेरी लेस अमाउंट, दोनों मूव कर रहा है, दैट्स व्हाई as a majority and minority carrier both moves, that's why I told you bipolar. Bipolar means both electron and hole. Okay, if it will be NPN type of transistor, so here this will be electron type, here this will be hole type, means electron भी move कर रहा है, hole भी move कर रहा है, as both carrier take part in conduction, that's why it's called bipolar. तो अभी समझ में आ रहा है bipolar क्यों इसको बोला जाता है?
Yes, sir.
Okay, so this is electron, this is hole, these are moving from this to this side, so I can get my current in this direction. Yes or no?
Yes, sir.
Okay, and
Yes, sir.
I can assume one current because ये जो कलेक्टर में जो भी करंट पास करेगा, ये जो कलेक्टर में जो भी करंट तुम्हारा पास करेगा, वो मेजॉरिटी, ये जो मेजॉरिटी जो इमीटर से आया था वो भी पास करेगा और माइनॉरिटी भी पास करेगा. ये सर.
Yes, sir.
Okay, that means I'll get that is IC majority प्लस IC माइनॉरिटी, बिकॉज दोनों पास कर रहे हैं कलेक्टर में. जो इमीटर से मेजॉरिटी फॉरवर्ड बायस होते हुए आया है वो भी पास करेगा और रिवर्स बायस के वजह से जो तुम्हारा आता है मतलब क्या माइनॉरिटी वो भी पास करेगा. दैट मीन्स at the collector you are getting two types of current, that is majority current and minority current. That means your total collector current, that means that means your total output current, that means your total output current is nothing but sum of your majority current plus
Sir,
minority
I
current.
equal to IB plus IC.
Not IB plus IC, ये तो IE होता है. IE equal to IB plus IC. I am just talking about collector.
Yes,
अभी कलेक्टर के पास कितना पैसा पहुंचेगा, मतलब कलेक्टर के पास कितना कैरियर पहुंचेगा जो फॉरवर्ड होते हुए आया है इमिटर से और जो रिवर्स के रीजन से माइनॉरिटी आया है. फॉर एग्जांपल तुम्हारे पापा ने तुमको कुछ 1000 रुपीज फोन पे किए हैं, तो वो अमाउंट भी तुम्हारे पास आएगा, उसके वजह से तुमको एक स्क्रैच कार्ड ऐसे कुछ रिवार्ड मिलता है कि नहीं?
yes, sir.
Yes, sir.
You can think
Yes, sir.
you can think about just like that. तो मेजॉरिटी कुछ आ रहा है और रिवर्स बायस की वजह से माइनॉरिटी भी कुछ आ रहा है. दैट मीन्स तुम्हारे पास दोनों अमाउंट पहुंच रहा है, क्योंकि ज्यादा अमाउंट तो फादर का मनी होता है ना. तो you can neglect this phone pay rewards also. In the similar manner, you are getting collector currents. Okay, I mean your total collector current is nothing but majority current that you are getting from your forward bias case plus some minority current. Okay, that's why I mentioned that is IC is nothing but majority plus minority. Is that clear?
Yes, sir.
ओके, एंड ये जो मेजोरिटी है अभी मैंने बोला ना, ये अगर ये तुम्हारा सिचुएशन है, इधर तुम्हारा एन अमाउंट्स कैरियर जनरेट होता है, तो इधर क्या होता है अल्फा एन होगा, मोस्ट बिकॉज अल्फा इज अ बिगर नंबर मींस मोर टुवर्ड्स एन. That means you can say 95 to 98% of the majority will be reach over here. Yes or no?
Yes, sir.
Okay, that means your IC majority will be nothing but alpha times of IE. मतलब इधर तुम्हारा जितना करंट हो रहा है, अगर अगर इधर 100 कैरियर है, इधर तुमको 95 कैरियर चाहिए, मतलब इस कैरियर के वजह से अगर करंट तुम्हारा हुआ IE, तो इधर भी होगा अल्फा टाइम्स ऑफ IE. अगर इधर n हुआ था तो नंबर ऑफ कैरियर विल बी अल्फा टाइम्स ऑफ n. तो इस कैरियर के वजह से अगर करंट तुम्हारा IE हुआ, then because of this number of carrier, the current will be alpha times of I. Yes or no?
Yes, sir.
Yes, sir.
That's why I mentioned alpha IE plus minority. So minority is named as ICO. Okay. Okay. Is that clear?
Yes, sir.
So remember, this is a very two important equation. Okay, while you go for the next topic, because next topic के लिए ये दो equation बहुत important. It is a base equation. So what is the base equation? Remember, for the rest of the topic, we'll discuss about 2 points. One is IC major, so total IC collector current is equal to IC majority plus IC minority. And what is ये जो ओम प्रकाश अभी ज्वाइन किया था ना, अभी ज्वाइन कर रहा है, हेलो ओम प्रकाश, संग्राम, संगम संगम संगम, are you there? Okay, listen. So there are two equations where so there are two equations we'll just consider. So first of equation is your first equation is this. Your IC total collector current is nothing but IC majority plus IC minority, and this IC majority is nothing but alpha times of IE plus IC. This is the first equation, and second equation is your KCL equation. Already I told you that is IE is equal to IB plus IC. Remember these two equations. Okay, these two equations are too much important while you go for the next section. Is that clear?
Yes, sir.
Okay.
Yes, sir.
So this is all about your first part of the transistor. So what we come across this again, just recall it. So bipolar junction transistor. So bipolar because of electron and hole, junction because of two junction, transistor because you are transferring the resistance level from one to another. Okay, and in this case in the BJT we are considering the two equation. One equation is IC is equal to alpha times of IE plus ICO, and the KCL equation, that is IE is equal to IB plus IC. So this is nothing but brief whatever we have discussed till now. Clear? Okay.
Yes, sir.
Yes, sir.
So the next part is
Yes, sir.
configuration. Next part is configuration. So what is the configuration? So configuration के लिए एक चीज तुमको सोचना पड़ेगा, ये कितना configuration हो सकता है. Okay. Just think about one thing. Suppose ये तुम्हारा सिस्टम है. ये तुम्हारा क्या होता है? सिस्टम. ये क्या है तुम्हारा सिस्टम? बोलो, बोलते क्यों नहीं? अगर शो करके आंसर
Yes,
करना
sir. Yes.
ओके. सपोज दिस इज सिस्टम एंड यू वांट टू गिव द इनपुट. अगर तुम इसको इनपुट दोगे एंड आउटपुट लोगे, अगर तुम इसको इनपुट देना चाहते हो इंडिविजुअल, सेपरेट इनपुट सेपरेट आउटपुट, तो इनपुट के लिए कितना टर्मिनल चाहिए मुझे?
Sir,
अरे मैं उसको इनपुट देना चाहता हूँ तो मुझे कितना टर्मिनल चाहिए?
two.
टू टर्मिनल चाहिए इनपुट देने के लिए. टर्मिनल 1, टर्मिनल 2. आउटपुट उसको निकालने के लिए कितना चाहिए सेपरेटली?
2.
Same to
That is number 3, number 4. So how many terminals total I need? I need 4 terminals. I need, yes or no?
yes, sir.
बट मेरा जो
Yes.
ट्रांजिस्टर है उसके पास कितना टर्मिनल है?
3 terminal.
तो
Three.
मुझे क्या कर, तो मुझे तो ट्रांजिस्टर को एक सिस्टम की मतलब जैसा यूज करना होगा ना. उसको कुछ इनपुट दूंगा, उससे कुछ आउटपुट लूंगा. yes or no?
Yes, sir.
तो मैं कैसे काम करूंगा? मुझे तो 4 टर्मिनल चाहिए.
एक को
Suppose
कॉमन लेंगे.
that is the thing. Okay, we have to make one terminal as a common. Okay, based on that we have 3 configuration. इसीलिए हमारे पास 3 configuration. ठीक है? Is it clear?
Yes, sir.
Okay, so why we have 3 configuration? Because one terminal you have to make common. Okay, because of the based on that, अगर तुम बेस को कॉमन करते हो कॉमन बेस, इमिटर को कॉमन करते हो कॉमन इमिटर, कलेक्टर को कॉमन करते हो कॉमन कलेक्टर.
Yes, sir.
Yes.
Is that clear?
Yes, sir.
Okay, so one by one we'll come across one common configuration. Okay, so let us come to first one, common base. First one, common base. Okay, so what do you mean by common base? तो मैं पहले मतलब हमारा जैसा कॉन्फ़िगरेशन दिखाई देता है मैं इसी तरह करता हूँ. तो ये तुम्हारा बेस है, ये तुम्हारा इमिटर है, ये तुम्हारा कलेक्टर. ये सर नो, ठीक है?
Yes.
ओके, तो ये चीज को मैं कॉमन कर लूंगा. तो ये हमेशा कॉमन वाले मिडिल में अगर रहेगा तो अच्छा लगेगा. तो उसको इसके लिए क्या क्या मैं उसको मैंने ऐसे रोटेट कर लिया. अगर रोटेट करने से इसी तरह दिखाई देगा। इज दैट क्लियर?
Yes, sir.
Yes, sir.
तो अभी मैं इस चीज में क्या करूंगा, हमेशा मुझे पता है इमीटर में मैं इनपुट दूंगा, इमीटर बिकॉज दिस इज द इनपुट सेक्शन। तो अभी 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 मेरा बेस कॉमन हो गया, देखो बेस को मैंने ग्राउंड कर लिया और इमीटर के साइड में मैं इनपुट दूंगा, तो ये मेरा इनपुट वोल्टेज होगा एंड आउटपुट में ये मेरा वोल्टेज हुआ। ओके, तो मुझे उसको क्या करना है, कौन सा मोड में चेक करना है? एक्टिव मोड में ऑलरेडी मैंने बोल दिया, यू हैव टू कंसीडर ऑल द ट्रांजिस्टर इन एनपीएन टाइप एंड एक्टिव मोड। यस और नो? एक्टिव मोड मतलब क्या होता है, इनपुट जंक्शन तुम्हारा क्या होगा, इनपुट जंक्शन फॉरवर्ड बायस होगा, आउटपुट जंक्शन रिवर्स बायस होगा। तो इनपुट जंक्शन फॉरवर्ड बायस होगा मतलब ये तुम्हारा एनपीएन ट्रांजिस्टर है, तो ये एन मतलब नेगेटिव साइड, ये पॉजिटिव साइड, तो ये वाला फॉरवर्ड बायस हो गया। तो ये वाला देखो एन, ये नेगेटिव, ये एन, तो इसको मैंने पॉजिटिव के साथ अटैच किया, तो ये फॉरवर्ड बायस रिवर्स बायस हो गया। So input junction forward bias, output junction reverse bias. So now it perfectly works as an amplifier. Okay.
Yes, sir.
Or any doubt?
No, sir.
So and the purpose is here I have to feed my weak input signal. इधर मुझे output amplified signal मिलेगा. That is called voltage amplification. तो कैसा होगा just observe करो. इधर input parameter क्या है मुझे quickly बताओ. इनपुट पैरामीटर मतलब इनपुट में कौन सा वोल्टेज दे रहे हैं, कौन सा करंट दे रहे हैं। तो इफ यू लुक एट दिस, बिकॉज़ दिस इज योर इनपुट सेक्शन, इफ यू लुक एट योर इनपुट सेक्शन, एट द इनपुट सेक्शन करंट इज IE एंड वोल्टेज इज दिस योर बेस टू मीटर। यस सर? नो?
Yes, sir.
तो सेम थिंग इज मेंशन। यस सर? नो?
Yes, sir.
And if you look at your output side, your output current is IC and your output voltage is nothing but voltage between collector and base, that is CB. Yes or no?
Yes, sir.
And
Yes,
you
sir.
may ask, sir, why you are writing BCB, why not BC, VBC we can write, because current is flowing from this to this, collector to base. So that's why higher potential will be written as fast than lower potential. Is that clear?
Yes, sir.
Okay, that's the output parameter, that is output current and voltage. Okay, fine. Fine.
Yes, sir.
Okay, again go to the equation. Already मैंने बता चुका, दो इक्वेशन हमको चाहिए। IC is nothing but alpha times of IE बोल दिया था, plus ICO, another equation is IE is equal to IB plus IC। ये दोनों इक्वेशन को मैं कंसीडर करके अभी इसका एम्प्लीफिकेशन क्या होता है मैं इसको डिराइव करूंगा। ओके, तो लुक, सो ये दो इक्वेशन मैंने जो बोला था, दैट इज द बेस इक्वेशन फॉर ऑल कॉन्फ़िगरेशन। ओके, yes or no? And as this is the base common, as is the base common, now this ICO can be written as ICBO. That is your minority current going from collector to base with emitter open. This can be read as current, that is minority current flows from collector to base, collector to base with emitter open। जब तुम्हारा emitter open होता है, at that time collector to base जितना reverse current flow कर रहा है, that is called ICBO। okay, remember this ICO का नाम बदल जाएगा for different configuration। common base के लिए CBO, then common का emitter के लिए ICO, ऐसे उसका नाम बदल जाएगा। so be careful। okay,
Yes, sir.
is that clear?
Yes, sir.
Okay, so we mentioned the same equation over here, उसका नाम बदल करके हमने क्या किया, ICBO, and already we know the majority current is too much greater than this minority current, तो उसको हमने neglect कर लिया है। ठीक है, इसको अगर मैं neglect कर लूंगा, so I can write my IC will be approximated to alpha times of IE। yes or no?
Yes, sir.
And
Yes, yes, sir.
if I take my alpha to one side, so alpha is nothing but IC upon IE। yes or no?
Yes, sir.
Yes, sir.
And this alpha, remember this alpha is called amplification factor. This called amplification factor, or you can say current amplification gain, whatever you can say। okay, and that is called, you can say, because it's simply a current gain, because output current by input current, because output में collector current है, input में base current है, so output current divided by input current is nothing but current gain। yes or no?
Yes, sir.
And this is the current gain for which type of transistor, which type of configuration, common base।
Yes, sir. Common.
Yes, sir.
and also you can call it as an amplification factor। इसको मैंने लिख लिया। so alpha, remember what is alpha, अल्फा का एक्सप्रेशन होता है IC अपॉन IE, एंड अल्फा को क्या बोलते हैं, एम्पलीफिकेशन फैक्टर फॉर व्हिच कॉन्फ़िगरेशन, दैट इज कॉल्ड कॉमन बेस कॉन्फ़िगरेशन। उसी तरह कॉमन इमीटर का कुछ अलग सा सिंबल होगा, कॉमन कलेक्टर का कुछ अलग सा सिंबल होगा, सभी का एम्पलीफिकेशन फैक्टर निकलेगा। ये सर नो, सभी का एम्पलीफिकेशन फैक्टर निकलेगा, लेकिन उसका सिंबल अलग अलग होगा। ओके, तो अभी हमने क्या पढ़ लिया, अभी हमने पढ़ लिया दैट इज द current amplification factor, or you can say the current gain of your common base configuration, which is nothing but alpha. Is that clear?
Yes, sir.
And already मैं बता चुका हूँ अल्फा वैल्यू बहुत ज्यादा होता है, अराउंड 0.95 से 0.98 तक. Okay, that is more towards 1. Okay.
Yes.
Okay, so okay, so look, another part also already we have discussed, that is I, then go for the second equation, I is equal to IB plus IC. अभी मुझे पता चल गया IC मतलब क्या होता है, अभी पता चला ना, IC के जगह में क्या लिख सकता हूँ, अल्फा टाइम्स ऑफ आई. यस और नो?
Yes, sir.
तो अभी क्या करूंगा, दोनों को एक साइड में रख लूंगा, तो क्या हो जाएगा, IB इज इक्वल टू 1 माइनस अल्फा टाइम्स ऑफ आई. यस सर नो?
Yes, sir.
Yes, sir.
Yes.
Okay. Okay, so this is the base equation. Okay, so just hold on. So remember, so what we have discussed for case of common base. अभी common base में हमने क्या क्या पढ़ लिया, common base में first पढ़ लिया what is the equation of alpha. Alpha is nothing but IC upon IE, and what is the equation for output current. Okay, where output current is nothing but alpha times of IE plus ICBO. Okay, is that clear? ये सभी का, जैसे कॉमन बेस का ये दो इक्वेशन हमको मिल गया, उसी तरह सभी कॉन्फ़िगरेशन कॉमन इमीटर एंड कॉमन कलेक्टर का भी, सॉरी कॉमन इमीटर कॉमन कलेक्टर का भी ऐसा एम्पलीफिकेशन फैक्टर का इक्वेशन निकलेगा, आउटपुट करंट का भी इक्वेशन मिलेगा. ठीक है, इसको तुमको याद रखना है. ठीक है,
Yes, sir.
लिंक आ गया क्या तुम्हारा?
Yes, sir. Chemistry sir का link आ गया.
ओके ओके, ठीक है, तुम अभी ज्वाइन करोगे, जस्ट वेट 1 मिनट, आई विल टेक अटेंडेंस. ओके,
Yes, sir.
रिमेंबर इधर हमने जैसे कॉन्फ़िगरेशन बनाया उसी हिसाब से, मतलब प्रोसीजर दोनों इक्वेशन लोगे, IC मेजॉरिटी इज इक्वल टू IC टोटल इज इक्वल टू IC मेजॉरिटी प्लस IC माइनॉरिटी, एंड I इज इक्वल टू IB प्लस IC, ये दोनों को कंसीडर करके ये सब इक्वेशन तुमको मिलेगा. ठीक है, तो लेट मी टेक द अटेंडेंस, जस्ट वेट 1 मिनट. So don't, okay, okay, thank you all.